Did you know that sometimes a smaller, simpler AI model can learn to perform just as well, or even better, than a much larger, more complex one by essentially being tutored by it? This isn't magic. It's a powerful technique called knowledge distillation. Imagine a brilliant, experienced teacher sharing their wisdom with a promising student. The teacher has mastered intricate concepts, not just the final answers, but the nuances, the soft probabilities, the reasons behind their decisions. Knowledge distillation works similarly. A large pre-trained teacher model, rich in acquired knowledge, guides the training of a smaller, more efficient student model. Unlike traditional training, where the student only learns from hard labels, like "this is a cat," distillation leverages the teacher's soft probabilities. For instance, a teacher model might classify an image as 80 cat, 15 dog, and 5 bird. These aren't just one-hot labels. They convey how close an image is to other categories, a form of dark knowledge. The student model learns to mimic these nuanced outputs, typically through a modified loss function. Combining the soft targets with the true labels, often using a temperature parameter to smooth the teacher's probability distribution, making the student's learning more robust. Think about deploying sophisticated AI onto devices with limited computational power, like smartphones, drones, or embedded systems. A massive deep learning model trained on a server farm is too big and slow, but a distilled version, significantly smaller, can run locally, enabling real-time object detection for augmented reality apps or instant voice assistance without needing constant cloud connection. This transforms what's possible at the edge. While methods like pruning or quantization reduce model size by removing parts or simplifying data types, distillation transfers superior knowledge. It's not just making the model smaller, it's making a smaller model smarter, often exceeding the performance of a student model trained from scratch, even if that student has the same architecture. Beyond efficiency, distillation can actually improve model robustness against adversarial attacks, because the dark knowledge from the teacher often contains more generalized, less brittle representations. It can even aid in transfer learning, or help train models in scenarios where direct access to sensitive data is restricted, by only sharing the teacher's knowledge rather than the raw data itself. Knowledge distillation reminds us that true intelligence in AI isn't solely about model size or brute force computation. It's increasingly about the effective transfer and distillation of learned representations, making powerful AI more accessible and more adaptable across an ever wider array of real-world challenges.